wanted to finish the problem that we started in class, which was number 26 on page 100. And for this problem, we had gotten as far as taking a lawnmower and getting the mass and doing the free body diagram, which meant putting the weight of the lawnmower in, a normal force, not natural force, but normal force, coming up from the ground. And the problem tells us that there is a frictional force, and we understand it is opposite the direction of motion of the lawnmower, which is going this way. And finally, there was an applied force of the person pushing on the lawnmower, which is going like that. And we're told that that's at a 45-degree angle. And for the first part of the problem, we are told that F is equal to 88 newtons. So, we have our free body diagram. Now, we need to make sure that all of our forces are split into horizontal and vertical components. Fortunately, the normal force is pointing straight vertically, the frictional force is straight horizontal, and the weight is straight vertical. But our force F right here is at a 45-degree angle, so we're going to need to split that into the two components, and notice that the two components take me from the beginning, the tail of F, all the way to its head, which is right there. And having done that, we're now going to cross off F because it is being replaced with its two components. And we're going to find the value of those two components. This one, the vertical, is going to be 88 sine 45 degrees, which you can check on your calculator as 62 newtons. And the horizontal will be 88 cosine 62 degrees, 45 degrees, which is also 62 newtons. Having done all of that, we're now ready to make a decision. Newton 1 or Newton 2? And what we're told in the problem is that the lawnmower moves forward at a constant speed. In other words, neither the direction nor the magnitude of the velocity is changing, which means that the acceleration of our lawnmower is 0. And that means that we're going to use Newton 1. Having made that decision, we're now ready to do the sum of forces in the x and the y directions separately. So I'm going to do the sum of forces here in the x direction in blue. And we notice that there are exactly two horizontal arrows, which are our x forces. And so we add them up. We have the 62 newtons pushing to the right for the positive direction, and we have the force of friction pulling to the left in the negative direction. And so we have those two, and they add up to 0. Well, this immediately can be solved for the force of friction. So we find that the force of friction is 62 newtons, which is the answer to part B. Now we come back and look at the forces in the y direction, which are the vertical arrows. And those forces are going to be the weight, the normal force, and the 62 newton applied force right there. The 62 newtons is pulling down, the normal force is pushing up, and the weight is pulling down. And we'll just do a quick sign check here. Newtons. I forgot my newtons here. We do a quick sign check from our equation. The 62 should be going down, and it is. The normal force should be pointing up, and it is. And the 140 weight should be pulling down, and it is. And all of those add up to 0. Well, this is also an easy solve and it gives us a normal force of 62 plus 140, which is 202 newtons. And that's our normal force for part C. Please notice that this was an example of a problem in which the normal force did not equal the weight. So don't be one of those students that assumes that the normal force is always equal to the weight. Now in part D, they changed things up a little bit. And they ask us, what force must the person exert on the lawnmower to accelerate it from rest to 1.5 meters per second in a time of 2.5 seconds. Okay, so we have to come back and ask, well, what changes now in the problem with this new set of things? The free body diagram, generally speaking, is not going to change, but all of the values of the forces might very well change. We wonder, could the direction of the force change? Well, it possibly could, but the problem seems to imply that the force is going to remain at the same angle. I think we'll make that as a simplifying assumption, although we're not told that this is the case. So we're going to have to redo our free body diagram. Here we are, 14 kilograms. The weight is still 140 newtons. That does not change. But we are not guaranteed that the normal force will remain the same. We are told that the frictional force remains the same. So we're going to mark that as 62 newtons pulling back. And there's our frictional force. And we know that the force here has to change because that is the force that's being asked about in the problem. And we're making the simplifying assumption that that force will remain at the same angle. Okay? Now having done all that, we once again have to split our force into components. So we're going to have a force F sine 45 going down, which is 0.707 F. And we're going to have a force F cosine 45, which I'm kind of out of room for. And that's 0.707 F also. And you can check that on your calculator. Now we're going to do sum of forces, first in the horizontal direction, and then in the vertical direction if needed. The sum of forces in the x direction is going to be equal to the sum of just the horizontal forces. And my horizontal force here is 0.707 F, pushing forward, minus the 62 Newton force, which is pulling backward. Now, we come to the second way in which our problem changes. Because we are accelerating from rest to 1.5 meters per second, we see a change in the motion. We start at rest, we go to 1.5. A change in the motion means an acceleration. And therefore, we're going to use Newton 2 for this problem and not Newton 1 because the acceleration is not 0. What is the acceleration? Well, actually, let's watch the motion and calculate from that. From this, I think it's pretty clear that we want to use v equals v0 plus at to find the acceleration of the lawnmower. We're starting at rest, and we have a final speed of 1.5 meters per second, and all of that happens at a time of 2.5 seconds. And so solving for A, we get A is equal to positive 0.60 meters per second, or meters per second squared. So having done that, we're ready to come back now and apply our acceleration to Newton's second law. Here's the sum of forces, and that sum of forces is equal to mass times the acceleration of the lawnmower. And I probably should have written my formula before I got going on that. Here's Newton's second law. Well, let's see what we have here. 0.707 F minus 62 newtons is therefore equal to 14 times 0.6, which turns out to be 8.4 newtons. Adding 62 to both sides, and dividing both sides by 0.707, we get 99.6, which is rounded to two significant figures. Wait a second. That's going to be 100, but how do I write 100 with two significant figures? Aha! The only way to do that is with scientific notation. 1.0 times 10 to the second newtons. And having done this, we don't even need the sum of forces in the y direction. That's pretty cool. I'll see you on Monday. Have a good weekend.